Hello and welcome to this LangChain tutorial. So in the previous video, we have already seen usage of vector stores, right? Where you can store the embeddings into a vector store and then query to get relevant documents. Another way to get documents by passing a query is by using retrievers, and that is the topic of this video. So in LangChain, actually, their retriever is an interface using which you can get relevant documents from the source by passing an unstructured natural language query, right? You can write your own query in English and it will get you the relevant documents. So all retrievers in LangChain, so LangChain has many retriever implementations. So they all accept a string query as input and return a list of document objects as output. So that's what you will get by using any of the retriever. You have to pass string as an input. You will get a list of document objects. So now the question is, you may say, okay, same thing we get using vector stores also, right? You can store the documents in a vector store and then do a similarity search to get the document which are semantically similar to the query. So that we can do with vector store also. Then what does a retriever offer actually? So that is true that you can use both vector store and retriever to get documents by passing a query. But one thing is retrievers are more general than a vector store. So using retrievers, you can get data from various other sources except vector stores. So as I said, LangChain provides many retriever implementation to get data from various different sources. Some of these sources are Amazon, Azure, Google Drive, Wikipedia, and many more actually. So if you want to see the whole list, you have to go to the LangChain documentation, and there you can get that retriever implementation list. And another difference from vector store is that retriever does not need to be able to store documents, only to retrieve them. Thus the name retriever. So vector store gives you the functionality to store and then do a similarity search, whereas retriever is only to retrieve. So for that, what you can do is, one way to use retriever is you can convert any vector store to a retriever using as underscore retriever method, so that you can call on the vector store instance and your vector store itself is converted to a retriever. One important thing about retriever is that retriever is a runnable. So every retriever implementation in LangChain extends the base retriever abstract class, and this base retriever in turn implements runnable interface, which means every retriever itself is also a runnable. So what does that bring to the table? That gives you the ability to use retriever also in pipeline using LangChain Expression Language. So you can use retriever in a workflow like this, right? So that is also one advantage of retriever. So with that, let's come to an example where we'll do the same thing. We'll convert one vector store to a retrieval and see how we can use it. So for that, what we need is these two classes are same. So I've just copied it here, which we have already done in the previous video, how you can load the document, split it, and get the embedding model. So all that was written in util.py class, all the utility function. Then there was one other file, chromadb underscore util.py, where we had all the functionality related to vector store, and vector store used is chromadb. So there we get the chroma store by creating a chroma instance where we pass the collection name and persistence directory and which embedding is used, and then load data where we can say kick off all the functionality of loading the documents and splitting it and then actually adding it to the vector store. And this particular file is already executed also. So this function will be executed. so that we have everything already done of this process of loading, splitting, and having data in the vector store. So that I've already explained in detail in the previous video. So these two classes are same. Then we have to create a new file where we convert this vector store into a retriever and then use it. So for that you can create a new file. Let's call it vs retriever. Okay, so in this vs retriever, first thing we have to get some imports, which is not much. You get chroma and get chroma store function from this file, chroma dv underscore util. So chroma dv underscore util, import this. Now using that you can create a vector store instance, get chroma store. So now we have the instance. Using that we can convert it to retriever. So let's call it retriever equal to vector underscore dot, method is as underscore retriever. So that will convert your vector store into retriever. Here itself you can pass some configuration how you want the search to happen. So search underscore type equal to similarity, that means I want similarity search, and with that you can pass some other keyword arguments also. So search underscore k equal to, I'll pass only one k for now, which means how many documents. Let's say 3 documents only I need. Alright, so search underscore k works with the dictionary and this similarity search. Now we have this retriever, so that we can invoke now. Retriever dot invoke. So same document PDF which was related to insurance, so I can ask relevant query. What is the waiting period for the pre-existing diseases? So this will invoke the query, get you the relevant documents. Now we have the document that if we want, we can print. So for I this enumerate docs. So what I'll do is I'll get this by enumerating, then I can print where I can pass content I plus 1. With that I can doc, and from that I'll just take the first 500 lines of characters only, rather than printing the whole document. And in this I actually not doc, right? From that I need page underscore content. So page underscore content, and from that we get this many. So content I plus 1 because it starts from 0, then page underscore content. In that I need 500 characters. So that's it. That's how you can convert your vector store to a retriever. If I try to run it, dot slash is in L9, name is vs retriever. Okay, so I am directly running it because I already have done that. This I've already run, so I have data in vector store. Okay, so there was one error actually. This docs, actually it should be documents, so I changed that. With that I'm getting the relevant results for waiting period. All right, so that's how you can convert your vector store into a retriever and use that to retrieve the relevant documents. So there is one more thing related to retriever in LangChain, which is maximum marginal relevance retrieval. So with MMR, actually, it is a re-ranking technique used in search and information retrieval to reduce redundancy while maintaining high query relevance. So what does that actually mean? Is that if you do a similarity search with the LangChain retriever, there is a very good chance that all the return chunks are very similar actually, and you have kind of data redundancy, so you don't get much diversity, and that's what you get with MMR. So that will try to select a new document that is both relevant to the query and diverse compared to the already selected document, so it brings that diversity into picture. So MMR tries to balance relevance to a query with variety in results. All right, so that's what you get with MMR. So what you have to do is, in the previous example, we used a search type as similarity. Here with MMR, you can give that search underscore type as MMR in that as underscore retriever method. Apart from that, in the example, we just used K in keyword argument. So there are some more like K we have already used, which is number of documents to return. Apart from that, you can give fetch underscore K, which is the initial number of documents which are fetched from the vector store. Then actually it will do some re-ranking and scoring and give you these K document out of this fetch underscore K document. And this is the main one with MMR lambda underscore mult. That is what will control the diversity. It has a number between 0 and 1. 0 or towards lower means diversity is increased, and higher value means more towards 1, emphasizes relevance. So that's how you can use search type equal to MMR. That is the instance creation example where you create with search type MMR. So in the previous example, you can change yourself and see is there any difference in the result when you use search type as MMR. All right, so that is about maximum marginal relevance retrieval. Okay, so now let's try to use one of the inbuilt retriever implementation. So as I already said, LangChain provides a lot of built-in retriever implementations. So we'll try to use Wikipedia Retriever and fetch wiki pages from Wikipedia using this retriever. So for that, what you need is you have to install LangChain under hyphen community package and Wikipedia Python package. So these two packages you'll need, and the parameters which you will use in Wikipedia Retriever. Let's just go through them once. So you have lang, which is optional. Default is English EN, or you can give the language for which you need wiki pages. Then how many document you actually want, load underscore max underscore docs. So how many raw Wikipedia documents are initially fetched? That is not the exact result actually. So it will fetch some initial document, then do some ranking and filtering, and then actually give you top K results, so that you can configure with top underscore K underscore results how many results you actually need. You also have load underscore all underscore available underscore meta. So by default, it gives you some metadata. So like published date and title and summary. If you need other fields, then you will give it as true. Default value is false. So these are some of the configuration or arguments which you can configure with Wikipedia Retriever. So with that, let's try to create a retriever. So I will do it here itself. In retriever, I will write Wikipedia retr demo.py. Okay, so as I said, you will need, so in requirements.txt, you will have to put Wikipedia and LangChain underscore community also. And you have to install these two. I've already done that. So that is why I can get from this retriever from LangChain underscore community, and it uses internally that Wikipedia package. So then I can create a retriever equal to this Wikipedia retriever. There you can give some arguments which we have just discussed, right? So load underscore max underscore docs. Let's say maximum document I want is 6, and top underscore k underscore results I want is 3 out of this. So first 3. So it will do some re-ranking and give me first 3 results. And there is actually one more configuration, which is I want only these many characters. So doc underscore contents underscore char underscore max equal to 2000. So from each wiki page, I need only 2000 characters, let's say. Doc underscore content underscore chars underscore max. So that's how you can get a Wikipedia retriever instance. Then you can invoke it. So docs equal to retriever dot invoke. So to send some search keyword, let's say I send Indian economy. Want to know something about Indian economy. Then I can again do the same thing, which I can get from here itself. So these docs. From that, I am trying to get the content and print it. So first 500 only I'm printing. So that's all you need to get a retriever, and you can search any, send any keyword to it. It will give you relevant pages from Wikipedia for that particular keyword. Then you can do this configuration, how many you need, how many result you actually need, how many content from those documents, all that you can configure. Okay, so let's try to run it. For that, I have to call dot slash. It is in L9 Wikipedia. Okay, so this gives me the result for the searched keyword. So content 1, which gives me some data about Indian economy. Then content 2 and content 3, because I'm asking for top underscore k underscore results equal to 3. So 3 results I'm getting. All right. So that's how you can use Wikipedia Retriever. Now, as another example, let's try to expand this example to create a workflow to retrieve data from Wikipedia based on the search keyword. That is what we are already doing. And then what we'll add to it is ask a query where documents retrieved from Wikipedia provide the context. So this query and context is what we'll send to the LLM to get a final answer based on this context, what context we are providing. So this is like a RAG workflow where you are augmenting the generation capacity of LLM by retrieving and providing your own document, right? So that's what we are trying to do, nearer to RAG workflow. All right, so that's what we are going to do now. Create that workflow using Wikipedia, where we pass the content which we get from Wikipedia and our query to the LLM. First thing, we have to create a file. So let's name it wikirag.py. In that, these are the ports. So Wikipedia Retriever I need. For that, you should have a Wikipedia package. And another new thing is I'm using this time NVIDIA is inference provider. So LangChain provides a package also for that. So you need to put that also in requirement.txt to install it. So LangChain -NVIDIA -AI -endpoints. Alright, so you should have this installed if you are going to use the same or whatever model you are going to use. So this is one thing. Then what we need is Wikipedia Retriever itself, that I'll get from here itself. Okay, so Wikipedia Retriever load maps doc 6 top k result. Let's make it 4. Okay, so first thing we have to write code about invoking this. So let's make it this time more generic, where we can send the query and it will call that particular invoke whatever keyword we send. So search underscore keyword, let's say. Then we can write retriever dot invoke for this particular keyword. That is what it will return. Okay, so another thing is we need to join all the results. So it will give me 4 results, right? 4 wiki pages or content from 4 pages. So I need to join all of them because I have to send that as a context to LLM. That is also one thing which you need to do. Join these documents which you will get. Okay, so getting the point, because you need to send all of them to the LLM. So you need to join them. Let's say join docs, whatever is returned from here, this thing. That's what it will take. And then this will return by joining them. This is /n dot join. And that I can use it like this, right? So I have I want to take dot page underscore content from docs, not from, for, right? For doc in docs. So that's how I can join them. So now I have the full context. So this is my first workflow. So let's name it retrieval underscore workflow, which involves calling these two. So keyword underscore retrieval. Since these are functions, so I have to call them as a wrapper around. So enable lambda will wrap this function to create or enable. Then another one. So same thing, enable lambda. And then this join underscore docs. So these two I'll call. This is my first workflow. This will give me all the content. So context for my LLM. Now this is done. Then what I can do is, let me get that prompt which I'll send to LLM. So here you see I'm making it very explicit that use the following context to answer the given question. If the retrieved context does not contain relevant information to answer the query, say that you don't know the answer. So it has to depend on this context only, which will be written from here to answer the question. It won't use its own reasoning. Right, so whatever content I'm providing and query, so it has to use the content to answer the query. Right, so it is very clear from these 2 lines. Now I can create a prompt which I'll send to LLM. So I can create a chat prompt template where I will give this system message. So chat prompt template dot prompt underscore messages, where you pass it as a list. In that I'll pass first thing is system. That will be my system message, correct? So this system message. I'm doing something wrong, right? This is not a dictionary, so I can give like this. Then I have to pass the human message. There, what I need is this context. So context would be what I pass it as context /n, then my question. So these two, when we invoke this chain, then we'll provide, right? And a question. Correct. So what I'll do is I'll pass as a human message a context, then a question. So this will be my prompt. Now I can create a chain. So here is one problem now. You see, if I use this prompt, then the model I have not yet created, right? So my model this time is on NVIDIA only, and I'm using Parser also. So usual thing what we generally do, prompt, model, and Parser. But if you see, if I invoke it, right, chain dot invoke where you send as a dictionary. So how will I send context now? Context will only be created once I call this workflow, correct? So that brings some complexity in it, because from here I can't pass the context. So first I have to run this particular workflow, then I'll have the context. So I can't pass context from here. What I can pass from here is initial keyword, you can say, which will be given here. So I can pass the keyword, which is again, let's say, Indian economy. And question I can pass. So question, that's how I given right now. Question. This let's say, what is the general outlook? So same thing for the Indian economy. Correct. So I can pass these two as my keyword, what I need, and my question. So let me finish this part first. What will it give me is response. Since I'm already parsing it, so I can directly print that response. Now let's tackle this problem. As I was telling, that when you are passing this, you cannot pass the context. But I can pass the keyword, but keyword from here it comes, I have to pass this keyword to this function, means this chain. From here it will call these two functions, then I have the context which has to be funneled here. So that's how it will run. For that, what I can do is, let's bring it to different lines so I can wrap it in brackets. Within that, then I have to pass another dictionary that will again be piped to it. So this prompt need context. So here I can give it context, but how will I get context? By calling this workflow, right? So I'll have to call this workflow, retrieval workflow, but it needs this keyword. So I have to pass this keyword to it. To do this, I can again call runnable lambda. Here also I pipe, and here I can do lambda x I can get that from so keyword, right? So it will extract this keyword from here, that will be passed to this retrieval workflow. It will come here, it will be passed here, and it will call the search keyword. Then that all documents will go to this one. Then it will join all of them. That will be returned here as a context, which this prompt will get, right? So this is the whole workflow. Now I have the context. Question anyway I'm passing here. For that, what you can do is you can just pass it as it is. So for that, what you do, you use runnable pass through. Pass through is another runnable which just pass the data along. So you will just pass it to the next, right? Whatever is next in the workflow. So we have this dictionary, we have this runnable lambda. This is also a function. So runnable pass through. Then we call this prompt model. So that's how it will work. So we have a little complex workflow. In the beginning, if you remember first class itself, I told you that by the end of it, we are coming towards end. Now we are moving towards some complex workflows where we have some sub workflow which will be invoked. That will give me the context. Then I call this workflow, and ultimately I should get a result. So let's try to run it and see. To use Python, though it will work without that also. L9, within that I want to use WikiRag. Okay, so if you see, this is the result I'm getting. So in the meanwhile, I did one more thing. I added just one print, so that just to ensure that whatever we are doing is, it is actually passing that keyword here. So if you see, it is passing Indian economy here in keyword retrieval. So whatever we have done, right, this complex workflow, it is indeed working, and it is passing that keyword here to retrieval workflow. Then it is retrieving the relevant document, joining, and then it is sending that as a context, and we are getting some result. So it is giving me some summary of whatever content it is getting. One more thing what I did is I changed it to 5 and 3 here, actually, because I was sending 3 4 requests continuously I sent. So Wikipedia may also do some rate limiting or restrict sudden API call from one source. So I just minimized the number, lowered the number, so that you can say reduce the risk of getting blocked for some time. All right, so this is, you can say, kind of RAG only, or a precursor to RAG, where we have created a workflow where you are sending the document to the LLM and query, and it has to use that context only to get the answer, right? So then using that, it will collate that, summarize it, and give you a natural sounding answer. So that's what you do in RAG also. You augment the retrieval with your own content, and LLM will generate the answer using that content. So you have got a first-hand experience of creating a RAG, but this time we use the content from Wikipedia. In RAG, you may use your own document. So first half of that we have already done. Some of that we have done here. So you can now get a very good idea what will be the next video where we'll actually create a RAG. That will be very simple for you now if you do it this one properly. So with that, we are done with the retriever, where we have done what? We have created a retriever from vector store. Then we used the inbuilt retriever class WikipediaRetriever. Then we created this whole workflow. So that's all for retriever. Thanks for watching the video. Please don't forget to like and subscribe.